power functions. So our objective for this video, we want to define, evaluate, and graph power functions. So let's start with define. What is a power function? A power function is any function of the form y equals a times x to the b, where a and b are real numbers and b is not equal to 0. The key to power functions is that the base is the variable. So here's my base of x, and that's the variable. The exponent is always a number in a power function. The base is the variable. Two examples that you're familiar with. Y equals x squared is a power function. We could write a 1 in front of the x. If you wanted to have an a, you could put a 1 right here. That's also called the squaring function. And y equals x cubed, called the cubing function, is also a power function. Again, the important piece, the base is the variable. The exponents are real numbers. So let's take a look at kind of evaluating and graphing power functions. If an object is dropped from a 144-foot building, the distance in feet that it travels after t seconds is given by the function f of t, which is the distance, is equal to 16 times the number of seconds squared, and we're ignoring air resistance for these problems. Okay, so couple of questions here. What is the lower limit to the domain of this function in the context of the problem? Well, our domain is our x values, and our x values are the time in seconds. And since there's no such thing as negative time, our time is going to start at 0 seconds and then go as far as necessary. So what's the lower limit for the domain? 0 seconds is the lower limit. We're not going to go into negative seconds because we're not going to go into science fiction. So if it even exists there. So 0 seconds is the lower limit of our domain. Then it says let's graph it for time between 0 seconds and 6 seconds. So I'm going to pull out Desmos. And I think you can see it here. Let's get it in there for you. Okay, let's graph this. Straighten it out. So here we are. Let's have a y equals, and I'm up here in the top left, 16x squared. 16x, and then here squared. And here is our function. We want to be between 0 and 6 seconds. So I'm moving over here. There's 6 seconds right there. So you can see here I am between 0 seconds and 6 seconds. And I'll kind of increase my y a little bit. There we go. Of course, we're in quadrant number 1. Our distance is going to be a positive number. It drops a positive, the distance it drops is positive. And these are seconds. 1 second, how far has it fallen after 3 seconds, 4 seconds, etc. So here is a graph. Looks like it doesn't fall very far in the first second. I probably can touch that point maybe. Yep, in the first second it's only fallen about 17, maybe 18 feet. By second number 2, it's fallen 66 feet, give or take, etc., etc. Okay, so we just graphed it. Letter C says, so we graphed it. We don't have to worry about, we'll just make use of that graph. We won't worry about writing anything down there. Is the graph concave up or concave down? Well, if we look at this graph, it is concave up. The bowl is heading, the bowl is pointing more up. An open bowl is certainly not pointing as a down bowl. So it's concave up. So let's note that. It is concave up. And letter D says, how long does it take for the object to hit the ground? Well, let's do this algebraically, and then we'll also do it graphically. We know our function is f of t is equal to 16t squared. And we know if it's dropped from a 144-foot building, it's going to hit the ground after it falls 144 feet. So the distance when it hits the ground is going to be 144 feet. Okay, again, f of t is the distance in feet. We could also replace that with a y if you wanted to. So we want to know, when is 144 equals 16t squared? Okay, let's solve this graphically. We don't need it. We'll worry about solving it algebraically some other time. Let's solve it graphically. So graphically, let's have y equal 144. This is the left side. And let's have y equal 16t squared. That's the right side. And then let's see what the intersection. What is the intersection? Okay, so we want this to equal that. So if y equals this and y equals that, when they cross is when we should know, they should be where the time, the time is at the time that it hits the ground. So let's go back to here. And so there's the first one. I already have the y equals 16t squared at the right side. I'll go to line 2 and put in y equals 144. And there's the line 144. And so when does this hit the ground? When is the distance fallen equal to 144? It looks like that would be right at 3 seconds. So after 3 seconds, the object that's been dropped hits the ground right there. After 3 seconds, the distance that has fallen is 144 feet. Okay, so thanks to the graph, at time equals 3 seconds, the object, I don't know, bowling ball or something, hits the ground. So there you have it. What is a power function? And how we graph power functions, and then we can use the graph, we can use the graph to solve problems.